Okay. In the morning, we were seeing sometime about the recommendation systems, right? So in the morning, we were seeing about the recommendation systems, and I just told you the difference between the search engine and the recommendation system using ML. And we saw the recommendation system is going to help us to filter out the preferences and give me only the suitable ones compared to the search engine output. That's what we saw in the morning, right? And we also saw the different types of recommendation systems. One is the content based, collaborative based, and the hybrid based. We are going to see what is the difference between content based and the collaborative based recommendation systems, okay, for which it needs user preferences. In both the cases, it is either going to take only the user preferences, and or it is also going to compare the user preferences with other users who are using the similar type of products, or looking for a place, or looking for the movies, etc. Okay, so in either of the cases, we need something called user preferences. What actually mean by the user preferences? Both content based filtering as well as collaborative filtering, CPF and CF. Recommendation systems require to understand the user preferences. We need to understand what is the preference of the users, and understanding how to model the we should understand the user preferences, and then we should see how to model such user preferences. For example, what do you mean by a user preference? In the case of the movie recommender from Netflix, we already saw in the morning. Netflix is one of the movie recommender system, where it will be taking the user preference is nothing but the rank provided by the users, from 1 to 5 stars, etc. And for example, in the case of the Amazon, Netflix, Flipkart, the product recommendation system, the user preferences may be of different ways. One is not bought, viewed, just bought. There are different type of preferences, and this are some of the this we call it as a labels. This Like the user preferences, the different type of user preferences that the different recommendation system uses, okay, are stated over here. It may be different ways. For example, here, weighted average expression, the number of reproductions or the number of clicks, or up down expressions, like, neutral, dislike, whatever we give, that is also one of the way of getting the user preferences. These are nothing but the different ways in which we can take the user preferences. One is like, neutral, and dislike. That is up down expressions. Another one is weighted value expressions. Weighted value means number of clicks that the user is making. That is called as a weighted value expressions. Sometimes a star rating, what we saw in the case of the Netflix, that is called numerical expression. So when you have a different star ratings that you will give, that is called numerical expressions. And for example, in the case of the Amazon, if I bought it, or I just viewed it, or I didn't buy anything. So that is actually called as a Boolean expression. What is used in the Amazon is nothing but the Boolean expression. What is used in the Netflix, according to these examples, it's called numerical expressions. Apart from that, the number of clicks that the user makes is called as a weighted expression, or when they give like, neutral, dislike, it is called as the up down expressions. These are the different ways of getting the user preferences, and this needs to be written in terms of a numerical number, and it will be
Ma'am,
used.
ma'am,
Yes.
some people are waiting outside the meeting, ma'am. Can you let them inside, ma'am?
I don't see anyone. Is there anyone? I don't see anyone. Okay, I don't see anyone except one person who requested for admitting. Okay, so these are the model user preferences. Okay, and as I told, there are two different types of recommendation systems. One is a content based, another one is called as a collaborative based. What is actually the content based? Content based in the sense, show me, it is something like this: show me more of the way that what I have liked. It means that I bought a book A, and similar type of books has been bought by some other users. Show me more of the same what I have. I bought the book A, recommend or find out more of the books similar to book A and recommend back to me. That is called content based filtering. This approach will recommend items which are similar to those the user liked before, and the recommendations are based on the description of the items and a profile of the user preferences. What I liked data science book. So it is going to recommend very similar data science books to me based on my previous history and based on my preference. That is what content based filtering approach is all about. For example, here, user A, he bought this particular product. So I'm going to find similar type of this products. There are so many similar type of this products, and all these products are going to be recommended back to the user A. Are you able to get? Show me more of the way what I have liked. I liked this particular product. I like this particular mobile design or mobile type, or I like this particular technology. I like this particular product. So the recommendation system will find out the similar type of movies, similar type of places, similar type of products, etc., and it will recommend back to me based on my previous preferences and my previous history. So it uses the profile about user's preference and the description of items along with user item interactions. What the user likes and what are the different type of items that I liked. So based on the previous history, it is going to recommend to me. That is called content based filtering. Very example for the content based filtering is Pandora. Okay, it is a music recommendation system. It uses up to 400 songs, but it is not the recent data. It may be using so many things, and it tries to find out similar songs based on my taste, and it will give me. So this is Pandora is a content based filtering. Okay, there is another, this is a movie recommendation system. So it takes a user profile, it takes an item description. What is the item here? It is music. So all the item descriptions are nothing but director who is like sang that song, who wrote the lyrics, etc., etc., how many instruments are there. All those things are nothing but the item descriptions. User profile, it's age, sex, etc. So based on this two, it is actually going to recommend my content based filtering, based on which it is recommend similar song by artist one. Okay, for example, I am very much interested in the artist one. You can see here, artist one, I am interested in a song one, song three, and song four. But artist two, I'm interested only in song one. So based on my previous taste, it is actually going to construct this, and it is going to recommend the songs which I like, or recommend songs by a particular artist. So here it is recommending all the songs by artist one. So that is actually called as similarly the movies. And so that is actually called as the content based filtering. See, you see here, I liked a particular song. It is actually going to get me all the songs which I liked, very similar to the songs that I liked, and it is going to recommend back to me. That is actually called as the I'll skip this. That is called as a content based filtering. The second one is called as a collaborative based filtering. What is collaborative based filtering? For example, there are similar users. This user bought this product, and this user has bought this particular product. And user A, though the one who got this particular product, also got this particular product. User A bought this particular product. when I want to recommend to the user B, because their likes are very similar, they are similar users, in that particular case it is actually recommend this particular product to this particular user. So here this is actually called as a collaborative filtering. What actually it means, tell me what popular among my like-minded users. For example, I got a particular brand of TV. I wanted to find out, tell me the users who got a similar branded TV, what are the other products that they bought. That is what this particular one is. But in the case of the content based, I got this particular TV, tell me very similar type of products around this particular TV or other products by this particular company. It is only based on the user preference. But in the case of the collaborative, by the very term you can understand collaborative, it is the collaboration filtering, where it tries to find out my similar users who got a similar type of TV brand, and they will try to recommend to me what are the other products that they have purchased. Those items they are going to recommend to me. It's very similar to the Amazon. When I buy a particular book, it will also tell me those who got this particular book also got all these different books. So which will help me to explore the purchase of the like-minded people, and so that I may also be tempted or maybe interested to buy such approach, such items. That is called collaborative based filtering approach. And there are two categories of collaborative filtering. One is called user based. It measures the similarity between target users and the other users. It tries to find, because what we are trying to do, I now someone needs to recommend to me a similar type of user. So what I need to work on, I need to work on a similarity measure. User based means it tries to find out the similarity between the target user and the other users. Target user is one who is requesting for the recommendations, or the one who has been targeted, and they try to find the similarity between that particular target user with other users. Item based, it measures the similarity between the items that target user rates or interacts with other items. So that is called item based. What are the items that the target user has rated or interacted or interested in the other items? That is called item based. Okay, now there is a measure called as a cosine similarity measure that will help us. For example, you can see here it is called as a cosine similarity measure. This particular formula is the one which will help us to find out the similar items or the similar users. Okay, so for which you need to fill up the utility matrix. This is actually called as a user item interaction matrix. You can see here this is called item based. In the case of the item based, it is a user and the corresponding items. So this is this table we need to fill in. It is called as a utility matrix. There are different number of users and the different number of products. Okay, so I'm going to fill this particular table. What this particular table corresponds to: C is the set of customers, S is the set of N items. So there are a lot of customers or the users, and S is the number of items. S is a set of N items. And matrix U with M into N to denote the past ratings of the users. So it is actually going to help us to fill in those details. For example, the user A, how much he has liked, maybe based on the one that I showed you before, maybe based on the ratings, based on the weights. If you remember, you see here, based on the Boolean expression, based on the numerical expression, or based on the weighted value, or based on the up down expressions, number of clicks, number of sorry sorry number of clicks and number of likes and dislikes, based on which this column needs to be filled in. It is called as a utility matrix. So this is capital U of I and J denotes user I likes item J. Okay, all these things are the likes and dislikes, which has been calculated from the labels or the user preferences, from the clicks, from the ratings, from likes and dislikes. It has been calculated. It is called as a utility matrix. It denotes what the user likes, or how much a user likes a particular item. But the problem here is there will be a lot of points that will be missing. For example, a user A, he cannot be exploring all the items because there are millions and millions of items available in Amazon, YouTube, etc. And I cannot go and search everything. And most of the places will be empty. And that's why it is called as a sparse matrix. This utility matrix is sparse. So, and the recommendation system needs to fill in all this sparse matrix. Sparse matrix means there are a lot of missing values. So the recommendation system used to fill up all these missing values, then only it can go for the similarity index calculation. Okay. So this is what this particular utility matrix, the problem with the utility matrix is nothing but lot of informations are unknown. And there is another matrix that is also available here. For example, here, uh, uh, okay, given a particular utility matrix. Okay, now there are a lot of places where I need to fill in, probably assuming that I'm putting 0 in all these particular places. What is the very next step is nothing but compute the similarity score. I'm going to calculate the similarity score. What is the formula for calculating the similarity score? It is to find out how much a particular person likes a particular item. So I'm trying to find out a similarity score. So for which I'm going to use this cosine similarity. There is also centered cosine similarity. There are two types of similarity calculations are there, which I will explain it and then I'll give you a short assignment. Cosine similarity and centered cosine similarity. And here the cosine similarity is between a user, it may be anything, A and B. It may be between two users or between a user and an item. In this example that I'm going to show you, it is the similarity between a particular item and a particular user. You see here, all the gaps have been filled with zeros. Now I'm going to find out the similarity between A and B. Here, A is nothing but a user and a particular item. B is nothing but a user and a particular item. So here, you see here how the numerator is. It is actually the summation of 1 to n. N is nothing but 7, okay? And AI into BI. EI into BI is nothing but between two users with the particular item. So A into B, right? So it is going to be 4 into 5 plus it is all the summation, okay? It is 0 into 5, you can see here, and 0 into 4, 5 into 0, 1 into 0, 0 into 0, and 0 into 0. That is your numerator. Given a utility matrix, the utility matrix can be derived using the user preferences based on the clicks, etc. And it is a sparse matrix and it needs to be filled in. Assuming here it is filled with 0 for the explanation purpose. And now using the similarity score, it is called cosine similarity score. We are trying to find out the similarity of likes and dislikes between two users. Okay, based on the different items that is available. So the numerator is take the first user and the second user values and then multiply it, and similarly follow the same thing for each and every item and add all the preferences. And denominator is square root of summation of AI square. What is AI? AI is nothing but the user. So here also I equal to 1 to n. N is nothing but the number of elements. So it is going to be AI square. It is 4 square, it is 5 square, it is 1 square. In the case of first square root. The case of the second square root, it is on B. So it is going to be 5 square, 5 square, and 4 square. That's what here it is. So the answer is going to be 0.38. You can see here the similarity between A and B based on this particular items is 0.38, whereas your diagonal is all equal to 1, because it is based on the different users. Okay, I'm comparing A with A, B with B, C with C, and D with D. So the answer is all 1. And now you can see here only B and D, the similarity seems to be a little bit bigger. So if I want to find out K similar users, for example, when I say K equal to 1, for recommending B, like only D is much closer. But for recommending for A, B is much closer if I keep K equal to 1. Are you able to get? K is nothing but the number of similar users. When I keep K equal to 1, to find out the similar users of A, only B is available because its similarity value is high. Because the distance between the similarity score between A and B is 0.38, 0.32, and 0. So naturally the answer is going to be 0.38. That, or I should say, A is very much similar to B. Their similarity is much higher. Are you able to get it? So I'm going to do the same. This is called as a similarity score, cosine similarity. There is another one, it's called as a Pearson similarity score. There are two steps. Here also it is the same thing. You can see here, we need to do two things. One is called as a calculate the mean value and calculate the centered value. What is a mean value? Here, the mean value is nothing but here 4 plus 5 plus 1, 10, right? How many values are there? There are only 3 values. That is what this 10 by 3 is. And what is this 4? It is the value of that particular cell. So value of the particular cell minus number of user preferences I have, the count of the user preferences I have for this particular user A on all the items, divided by the total number of non-zero values. So that is actually 3. So we need to fill in the entire table. Once we fill in the entire table, we calculate, see for example here, 4 minus 10 by 3, when I consolidate it, it is going to be 4 into 3, 12 minus 10, it is going to be 2 by 3. That's what this 2 by 3 is all about. So similarly, from this particular table, we are going to arrive at the same table. It is just the simplification of what is written in the utility matrix. Done. So once you have done that, you have to calculate your similarity score. How will you calculate your similarity score? It is the very same, A into B. So here it is 2 by 3 into 1 by 3. You can see here it is 0 into 1 by 3, 0 into minus 2 by 3, 5 by 3 into 0, minus 1 by 3, etc. Right? Divided by root of A and root of B. So what do I have in root of A? 2 by 3 the whole square, 5 by 3 the whole square, and minus 7 by 3 the whole square. That is what your similarity corresponds to. And into the square root of 1 by 3 the whole square to 1 by 3 the whole square minus 2 by 3 the whole square. Okay, so it is going to be 0.09. It is between whom and whom? It is between A and B. So between A and B, the answer is 0.09. Okay, so if you see here, A and B are related to a value of 0.09, but in the case of the C, it is not rated high, it is rated low, or the similarity is low, minus 0.55, and with D, it doesn't have any correlation at all. Okay, you should remember in the case of the utility matrix, if you're doing it for different users versus different elements, all the users and all the elements will be on the row and the column values respectively. But when you are calculating your similarity score, when you try to put it in the similarity score matrix, it is going to be number of users into number of users. That is, it is going to be a square matrix. Number of users into number of users. It shows a particular user, how much it is similar, it is having a similarity score with other user in the entire scenario. Okay, so that is actually called as a similarity score. Okay, this I will do it later. Okay, so this is what your cosine similarity and Pearson similarity score calculations. So what we try to do, there are three types: content based, collaborative based, and the hybrid based. In the case of the content based, it is all based on what I purchased historically, based on my historical preferences and the values, user preferences that I gave. I'm going to get further recommendations, that is content based. And in the case of the collaborative based, they try to recommend me from the users who bought a similar type of product as myself, and it is going to give lot of other products that the user has bought in. So it is what going to do. I got a particular TV set. The similar type of user, what items did they purchase? Because both of us bought the same type of TV, and what is the further products that has been bought by the user B? So that is going to be recommended to me. The similar type of people, what are the products they bought, just recommend to me. But I should know who are the similar type of users. That's why we actually calculate this particular, in the case of the collaborative filtering, these are the four values. It is actually based on the similarity score, right? So one is called as a cosine similarity, another one is called as a Pearson similarity score. So based on both these things, we will know which has got the highest value, and that particular item or that particular user's preferences and all will be given to us, or it will try to identify the similar type of user, I should say this way. Because if you see in this particular table, ABCD versus ABCD, and if you see in this particular table ABCD versus ABCD, it tries to analyze all the users, and it tries to find out who are very similar to me and try to recommend the products that they bought for me. Okay, that is actually the job that it is actually doing. Okay, so this is what your recommendation system is all about. We will see some more details in the next class. So now what I want you to do is, it is not something very tough, but I want you to do this and submit this as an assignment before you leave the before 5 p.m. today. Okay, so this is actually based on K nearest neighbor. And the first question is on Pearson correlation coefficient. Okay, using this data set, I need to find out the covariance and Pearson's correlation coefficient. And then using temperature and the number of customers, you need to calculate a simple linear regression line. And the second question is, you need to work on the KNN algorithm and try this particular values, and then show me when k equal to 4 or k equal to 5, what is going to be the label. The label is low or medium. It has got a set of input values. Okay, so these are the two questions which I'm going to upload it now in the GCR.